Let's take a look at number 4 in section 5.2. We're going to compute the integral, and we're going to use geometry, right? So we're given this definite integral from 0 to 2 of this function. What we're going to do is we're going to graph this function over this interval, and hopefully it will be a shape we recognize and can find the area using an appropriate formula. Well, what is the graph of the square root of 4 minus x squared look like? We looked at one like this in class. Remember, if I let y be the square root of 4 minus x squared, if I square both sides, I get this, and then adding x squared to both sides gives me this equation here. You should recognize this as the equation of a circle, right, of radius 2 with center 0, 0. So in general, remember we have x minus h quantity squared, y minus k quantity squared is r squared, is the equation of a circle with a radius of r, and the center of the circle is at h comma k. Whoops, that's a k. And so you can see in our case, both the h and k values are 0, and r squared is 4, therefore r is 2. Okay, so now when I graph this equation, of course, this is the equation of a circle. When we go back this direction and solve for y, when we take the square root here, we normally would take positive or negative. The positive root is the top half of the circle. If I did the negative root, that would be the bottom half of the circle. So we have the top half of the circle. Here's the graph of that from negative 2 to 2. Now we're integrating from 0 to 2. And so I'm going to start here at 0, and we're going to integrate. And hence, we're looking at the definite integral representing the area under the curve and above the x-axis. So notice that's just 1/4 of a circle, right? If we went all the way around, we'd have the full circle. So 1/4 of a circle. And what's the area of a circle? It's pi times the radius squared. Our radius is 2. I get 1/4 4 pi, which is pi. So the value of this definite integral from 0 to 2 is pi. Hope that helps.